Hello and welcome back. This is the 100th math lesson of the year. This is Algebraic addition of integers and Saxon math course 1. Let's just get started right here. The new concept for this is adding integers. And integers consist of the counting numbers 1, 2, 3, and so on to infinity, as well as the negative counting numbers, -1, -2, -3, on to infinity, as well as 0. All numbers that fall between these numbers are not considered integers. They would be decimals or fractions or those sorts of things. So if you look at this particular line right here, you can see that the dots on this number line mark the integers from -5 to +5. So you have -5, this would be -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. If we consider a rise in temperature of 5 degrees as a +5 and a fall in temperature of 5 degrees as a -5, we can use the scale on a thermometer to keep track of the addition. So like this, for example, imagine that you're at 0 degrees Fahrenheit, and if the temperature falls 5 degrees and then falls another 5 degrees, the resulting temperature is going to be at -10 degrees below 0. When we add two negative numbers, the sum is going to be negative. So -5 plus a -5 equals a -10. Imagine a different situation. If we will again start with a temperature of 0 degrees. First, the temperature falls 5 degrees, -5. Then the temperature rises 5 degrees, +5. This brings the temperature back to 0 degrees Fahrenheit. The numbers -5 and +5 are opposites. When we add opposites, the sum is going to be 0. -5 plus +5 equals 0. So if you're at 0 and you go down 5 and then you go back up 5, you're back to 0. Opposites are numbers that can be written with the same digits but with opposite signs. They are the same distance in opposite directions from the 0 on the number line. So if you have a -5 and a +5, they're both 5 from 0. One is just below the 0 and the other one is above the 0, and they're both 5 units from 0. Again, if we're starting at 0 degrees Fahrenheit, if the temperature rises 5 degrees, like +5, and then falls 10 degrees, -10, the temperature will fall through 0 to a -5. The sum is less than 0 because the temperature fell. So if you have +5 is where you're at, or if you're at 0 and you go up +5, you're now at 5 degrees Fahrenheit. But then the temperature drops 10. There's 5, and then there's 10 more. Then you're back to -5 right here. So -5 degrees Fahrenheit would be the temperature. All right, let's look at what we've got on the assignment here, or just run through some of these examples. So again, just in review, integers are the set of numbers that include all the counting numbers, their opposites, and 0. They won't include decimals like 2/10 or 3/10, 4/10, or 3/8, fractions, or any of those kinds of things. It's going to be whole counting numbers, their opposites, and 0. So if you're at 1,200,000, the opposite of that would be -1,200,000. All right, to add integers, as illustrated on a number line, you always begin at 0. Move to the right or left as indicated by the sign of the first number, then move right or left as indicated by the second number. So for example, if you had a +8 and you want to add a -5, this is what it would look like on a number line. Yet if you're at a +8, in this case, It says positive 8 plus a negative 5. So if you're at a positive 8, and then you go to a negative 5 from that, that would actually be 3. So the sum is positive 3 or 3. So I don't know. Yeah, the book actually got this wrong. The book should not have had this lined up as it was. It should have been here. This dotted line is 1, 2, 3. It should have been right here. You notice that. Sometimes publishers get these things wrong. This is where it should be. This is where positive 8 would be. And it would have been at the starting at the 0 right here, not that. And then if you're going to go negative 5, you're going to go from that position. You're going to go 5 back, which would end up being right to this position, which would be 3. This would be minus 5. So if you're at a positive 8, this would be the positive 8 right here, where it goes from this 0 to positive 8, and then negative 5 goes back this way. Just ignore what the textbook had there. This is correct here, however. The sum of those two things, positive 8 minus 5 is what it technically is, or positive negative 5 would be 3, or in other words, a positive 3. To add sign numbers, if the signs are the same, add the absolute values and keep the sign the same. So if the signs are different, subtract the absolute values and keep the sign of the number with the greater absolute value. For example, if you have a negative 5 plus a negative 3, that's a negative 8. If you have a positive 8 plus a negative 5, you end up with a positive 3. So if the signs are the same, in this case, this was a negative and this was a negative, you add the absolute values and keep the sign the same as you had in the problem. So this was a negative, this was a negative. The problem's answer should have a negative as well. And what's the absolute value of a negative 5 equals 5. That's just how far away from 0 is a negative 5. How far away from 3, that's absolute value looks like this. 2 straight lines, not parentheses. That equals 3. So in this case, you're supposed to add the absolute value. So the absolute value of 5, or negative 5, which is 5, plus the absolute value of a negative 3, which is 3, which equals 8. But then you have to carry the sign over that you had. You had this one and this one, and both of them have to be carried over into the answer. If the two signs are different, so in this case, you can see that different signs, you subtract the absolute values and keep the sign of the number with the greater absolute value. So what's the absolute value of a positive 8? Well, the absolute value of a positive 8 is 8. And then it says subtract the absolute values and then keep the sign of the number with greater absolute value. So subtracting that from the absolute value of a negative 5, which is 5. So 8 minus 5 equals 3. Now we have to look at which of these two things had the larger amount. What's the most, 8 or 5? Well, 8 is. So in this case, we have to keep that positive 3 because it was a positive 8. 8 is greater. Absolute value of positive 8 is 8. Absolute value of a negative 5 is 5. 8 is greater than 5. Therefore, we're going to keep 8's positive symbol for the answer. And it also equals this. You don't always have to write positive like that. So adding the opposite of a number to subtract it is called an algebraic addition. So instead of subtracting a negative, you'd add a positive. Instead of subtracting a positive, you add a negative. So change the number after subtraction sign to its opposite and then add. So here's an example of that. So if you have a negative 10 minus a negative 6, you can see that instead of subtracting a negative, you actually just add a positive. Why is that? Well, in math, two negatives make a positive. You can believe that. So two negatives next to each other like this actually just makes both of those positives. Okay. If it is 2, if you got negative 3 minus a positive 5, if these are different, then you can add the opposite. So in this case, if you're at a negative 3 and you want to add another negative 5, you end up with a negative 8. Negative 3 plus negative 5 is what it's like. If you were to go like looking at this as a opposite direction type thing too, you could think of it that way. If you're at negative 3 on a number line, this tells you to reverse course. This tells you to stay on that reversed course that you started right here. So if you're going negative numbers, means you're going to the left. And this just says continue going left, is what that's like. So if you're at a negative 3 and you're supposed to go left, and this says continue going left, 5, you'd be at a negative 8. Let's look at that a little closer here. So if you have a positive 8 plus a negative 5, here's where a positive 8 would be. So positive 8, then we're going to add a negative 5. So if you're looking at that, we're going to add a negative 5. Positive 8 starts from here, and it goes all the way to this point right here. And then if you're going to go negative 5, that's just 1, 2, 3, 4, 5. And that's where you end up. This was the negative 5 right here. This was the positive 8. And where do you end up? Well, you can see it very clearly there. This would equal a positive 3 or just 3. Let's look at it again here. If you have example 2, if you have negative 5, so I'd be like this. Negative 5 would be to this point. And if you're at this point at negative 5 and it says go to the right, but then it says reverse course, negative 3. So you're going to add a negative 3, but it says go this direction, but then immediately it says no, wait, go this way. So it's like adding another negative 5. So you're just going to add, or sorry, negative 3. So you're just going to add those 3 there, and that's where you're going to end up. So in this case, this one would be a negative 8 is where you're going to be for that one. So let's look at example 3. If you start at 0 and move 6 units to the left, that looks like this. 6 units to the left. So we're at negative 6. Then we move 6 units to the right, which basically returns us back to 0. 2 positives just means just moving to the right, basically. Just going to move right back 6 points, and this is where we're going to end up at, which means this answer is going to be 0. Let's continue on. Let's do this one. Example 4. Sometimes positive and negative numbers are written with parentheses like this. The parentheses will help you see that the positive or negative sign is the sign of the number and not an addition or subtraction symbol or an operation. So this is positive 6 plus a negative 6. Negative 6 and positive 6 are both opposites on a number line. Opposite numbers that can be written with the same digits but with opposite signs. Opposite of 3 is a negative 3, and the opposite of negative 5 is 5, which can be written as a positive 5. So on a number line, we can see that any two opposites are always going to be the same distance from 0. So if we're looking at this, if we're at positive 6, it goes all the way here. But it says after you go right, and then it says, wait a minute, turn around and go back the other way. Negative 6. So this is negative 6 here. This one was a positive 6. And it ends up being at that 0, much like our previous answer was over here. Negative 6 plus a positive 6 was 0. This one was a positive 6 plus a negative 6, which also ended up being 0. Let's find the opposite of each of these numbers. So basically, what's the, if you're at negative 7, you know that that's like over here on a number line. And then 0 would be right here. Here's negative 7. What would be the opposite? Well, it has to be on this side of the number line. It has to be the same amount, the same distance away as negative 7 was from 0. And hopefully that's pretty simple. Hopefully you can see that it's just 7. Same with this one. If you're on a number line and you got 10, and you have 0 in the middle, and then you have to have something over here that's equally distant as 10 is from 0. This one would be, the opposite would be a negative 10 in this case. Okay, and you could see that on a number line. If you had a number line with tick marks, you'd be able to see all those things. All right, let's look at another one. Example 6 here. If you're at a negative 10 minus a negative 6, this problem directs us to subtract a negative 6 from a negative 10. Instead, we may add the opposite of negative 6 to negative 10. So this one would be like just changing this. It would be negative 10 plus 6. These two negatives makes that one positive. So if you're at negative 10, that's right here. Negative 10, so we went negative 10 all the way to that point. And then it says go positive 6, which means to the right on a number line that's horizontal. If it was a vertical number line like a thermometer usually is, it would be going up. We're going to go back 6. There's 1, 2, 3, 4, 5, 6. This is where we'd end up stopping. And you can see that would be a negative 4. So that'd be the answer to that one. In example 7, you need to simplify negative 3 minus a positive 5. So instead of subtracting a positive 5, you actually have to add a negative 5. So really it'd be like this, negative 3 plus a negative 5. And really it doesn't change a whole lot. I mean, if you're going to start going left, then this just says continue going that way. That works. Or if you're going to say, hey, I got to go right, but oh, wait a minute, I need to turn around and go left. Still the same direction. But if you're at our negative 3, that's here on the number line. That's this point right here. And then it says add a negative 5. Negative 5 is to the left, so we're going to continue with that by adding 1, 2, 3, 4, 5. Okay, and then that gets us to this position right here. So that means the negative 3 plus a negative 5 is actually negative 8. All right, let's try some of these. It says draw a number line to show the addition for problems A and B. So let's just use this number line down here. We already have drawn on this one. But what about A? A is negative 3 plus a positive 4. This is what your number line would look like then. Negative 3, that's to this point, plus a positive 4. So we have to go back this way. And where are you going to end up with on this one for letter A? Where is it going to finish? If you had it finish at positive 1, you got it right. Positive 1, which also equals just 1. How about letter B? For letter B, let's say we're at -3 again. So we're right here, it says -3. So we go that far. And then it says add a -4. So in that case, I'm going to continue with add a -3. I have to go 4 more to the left, which ends up in that position. -7. All right, and it says do these mentally, C through H. So what is -3 plus a +3? Good job if you answered 0. That's correct. What about letter D? +4 plus a -3. +1 or just 1. That's correct. What about letter E? +3 plus a -4. -1. What about F? If you have a +10 plus a -5. +5, which is the same as just 5 also. How about letter G? -10 plus a -15. I just accidentally gave you the answer. Nice job if you figured that out. If it was -10 plus a -15, it would have been a -25. If you answered that, that would have been okay too. But here's what the problem was: -10 plus a -5. I misspoke, and the answer would have been -15. If you did the one that I misspoke, you would have got -25. And letter H. What is the answer to -10 plus a +5? -5 would be the answer there. What's the opposite of -8? +8. That's right. What's the opposite of a 4? -4. What's the opposite of 0? Trick question. The answer is 0. There is no opposite on that one. How about letter L? Solve each subtraction problem using algebraic addition. So that just means what you probably did mentally here anyway. But in this case, this would be like saying -3 plus 4. So what did you end up with when you answered that? 1 would have been the best answer in that case. This one would have been the same as a -4 plus a -2, which ends up being -6. And then this one, you'd end up doing this algebraically, would be +3 plus 6. And then this one, -2 plus 4. Remember, 2 negatives. Actually, it's not, let me go back. It's not multiply. 2 parentheses next to each other like that would be multiplying. This is just -2 plus 4. So that would be +2. All right, here's your quiz. Simplify 1 through 4. Numbers 5 and 6 are like using thermometers, temperature changes. Okay, make sure you get everything done by midnight tonight. Submit it. All right, thanks for listening, watching, and answering all the questions that you could. Have a great day.